So you can see that there is enough light in the room. The LED is at the brightest. Now I dim the LED. See, now the LDR has gone darkened. LDR is dark now. Now the LED is also dimmed. I slowly remove my finger. See, again there is light in the room. Again, see, I place my hand on it. The LED dims down, representing that the light in the room is also dimmed. That there is less light intensity in the room. I remove my hand. See, LED is now fully bright. Now I cover up the LDR sensor. It's like there is dark in the room. There is no light in the room. Now again, I remove the finger. See, it's simple as that. So that's how guys you can use an LED for indication of light intensity in the room using LDR. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can use a simple LED to act as a light intensity indicator. Now to measure the light intensity, we will be using an LDR sensor. LDR is a light dependent resistor. It has the ability to change resistance with a changing of light intensity falling on it. So guys, when the light falls on the LDR gives us an analog value. We will take the analog value into the PIC and then we will use an LED to display the light intensity in the room. Now, how an LED can display the light intensity in the room? We will use the brightness. We will send a PWM signal to the LED directly in ratio with the light intensity received. When the light intensity is highest, LED will be the brightest. As soon as the light intensity dims, LED will also go dimmer. And if there is no light in the room, LED will go off. So this is how it's gonna work with the fading in and fading out of the LED. So LED brightness will tell us that how much light is there in the room. So you can apply this to other projects as well, like for the temperature as well. You can use the brightness of the LED for the fire as well, for the smoke as well. With anything you can use this technique. So this is one of the cheapest way of indicating analog values. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, and this is the LDR sensor. And this is our LED having 2 pins, and LDR also has 2 pins. So let's first connect the LDR with the PIC. So I name the one pin as value, other pin as a 5 volt. You can shuffle these 2 pins, it doesn't matter. Now guys, the 5 volt pin you connect it directly to the VCC of the pin. This will act as a V reference pin. Now guys, for the value pin you will need a 10 kilo ohm resistor. You connect the value pin to the one end of the 10 kilo ohm resistor like this. Now from the same pin you will take out your output. For the output, you can use any available ADC pin of the PIC because LDR will give us output in the analog form. So we need to convert it into the digital form. For that, we will need analog digital conversion module of the PIC. So you can use any available ADC pin. I am going to use the AN0. That is pin number 2 of the PIC like this. Now from the other end of this 10 kilo ohm resistor, you will send it to the common ground like this. In this way, our LDR is connected. Now guys, let's get to the LED. As you can see that LED has 2 pins as well. One is longer and one is shorter. Remember that shorter pin of the LED is always the ground. You cannot shuffle these 2 pins at all. Shorter is the ground, longer is the 5 volt. Now guys, you connect the ground pin directly with the ground of the PIC. And for the longer pin, you will need a safety resistor. It can from 100 to 500 ohm. But remember that higher the resistance value, the dimmer the LED will go. So I am going to use a 220 ohm resistor. It's an ideal resistor with a PIC. So guys, you connect your 5 volt pin to the one end of the 220 ohm resistor. Then from the other end of this 220 ohm resistor, you can only use 2 pins now. Pin number C2 or C1. They both are the PWM pin. C2 is the PWM 1 pin and C1 is the PWM 2 pin. On the data sheet, they are labeled as CCP2 and CCP1 pins. Other than this, you cannot use any other pin for the PWM generation purpose because we are going to need the PWM. So for that purpose, you only have 2 pins here. So guys, in this way, our connections are completed. Now let's get to the hardware before we move on to the programming. So guys, this is the hardware over here. This is the LDR sensor, and this LED only, this will be used. Okay. So the light falling on this LDR will decide how bright the LED will turn on. So if the LED is brightest, it means there is the maximum light in the room. If it starts to dim, it means the light intensity in the room is decreasing. If the brightness is increasing, it means light intensity in the room is increasing. So that's simple as that. So let's get to our micro C for PIC. So guys, this is our micro C for PIC. Let me zoom in so you can see better. So guys, as you can see, this is version 7.2.0. You can use the latest version as well. Latest version is always better. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. I write Light Intensity Indication using LDR. So PIC16F877A is the one I'm going to use, and the crystal I have on the pin number 13 and 14 of the PIC16F877A is 20 megahertz. So you connect this crystal. Basically, it is a crystal found at the pin number 13 and 14 of the PIC. Remember that. PIC16F877A don't have any internal oscillator, so you have to connect a crystal there, and whatever the value of the crystal there is, you will select that value here. Click on Next and finish. Now guys, this window pops up. Before you do anything else, save your work. Press Ctrl S to save your work. Now go to the right. In the library manager, you have micro libraries. Expand it. Then expand the system libraries. Then select the ADC. We are gonna need the ADC library and the PWM library. So ADC library for the LDR, PWM for the LED, like this. Now expand the ADC library, and there is ADC init command. Double click on it. You copy this command, it will initialize all the ADC pins of the PIC like this, and then give some initialization delay. 10 will do fine. It's not necessary to give initialization delay, but I always suggest to give it in the one-time loop. Now let's get initialize the PWM pin as well. So you double click on this PWM1 init command. Remember that PIC has only two PWM pins here. See that C1 and C2. So here C2, pin number C2, that is pin number 17, is the PWM1 pin, and C1 is the PWM2 pin. So now in the library here, you will use the pin number 17. If you have connected the LED to the pin number 17, then use the PWM1 pin, else you will use the PWM2, and for the PWM2, the pin is pin number 16. So we are using pin number 17. So we will need the PWM1. So initialize the PWM like this, give some initialization delay, and the frequency I set is 5000, and that's fine for the LED. It depends upon the module to which you are going to send the frequency. For the LED, it's fine. So our PWM pins are initialized, our ADC pins are initialized. Now this is for the LED, and this is for the LDR. Now guys, let's get to the forever loop. I write while one forever loop starts here, ends here. And now guys, what I'm going to do here is that first of all, we will need to read the value from the sensor. So we will need a variable which will store the value. I take an integer, I call it LDR like this. Now guys, we write LDR equals to ADC underscore read from channel 0. Now here LDR is the variable which will store the value coming from the LDR, and ADC read is the syntax. So 0 is the channel. So I am using pin number A0 for that. 0 is the pin number 2. If you are using A1 pin, then you will write channel 1 here. If you are using A2 pin, write the 2 here. It depends upon whichever channel you are using. So I have my LDR connected to A0 pin. So I wrote here channel 0. Now guys, the next thing is we need to calibrate it. Now see that here. So we start the PWM. First of all, start the PWM. This command will start the PWM, else PWM don't work. You can write it in the one-time loop because here we need the PWM all the time like this. Give some initialization delay. So our PWM is started in the one-time loop. Now guys, the next thing is we give some duty cycle. Sorry for the PWM1. We are using PWM1 here. PWM1 start, and this is PWM1 set duty cycle. Copy this command from the example. Now what it says here, that it says that sets PWM duty ratio parameter duty takes value from 0 to 255. So it says that our maximum value is 255. While for the ADC, this is the command ADC read command. Here we have 2 power 10 bit of ADC. 2 power 10 means 1024. Our ADC sensor will take value from till 1024, while our PWM supports only 255. So here we need to perform some division. Whatever the value is received, we need to divide it by such a factor that it comes within the range of 255. So here what we do is that I write 1024, that is 2 power 10, divided by 255, that is for the PWM. So it's 4. So whatever the value is received, we divide it by 4. So I take another variable. You can also use the same, but I suggest you take a new variable because we have a lot of memory. This calibration. So I write calibration is equal to LDR divided by 4. So whatever the values of LDR will be divided by 4 to bring it in range of the PWM. So maximum value for the PWM is 255. Again, go to the PWM set duty cycle, copy this command here. Now instead of giving the duty manually, you allow this to give the duty. Now in this way, our LDR will directly give the duty cycle to the PWM. So whatever the intensity of the light is received, that intensity will be used to set the brightness of the LED. In this way, this LED will work as a, you can say, as an indicator. So let's build this code. Code is built successfully. Let's open the PIC16 programmer tool. Go to file, import hex file. This is the file I just created. I click on write. Let me zoom out and let's get to the hardware. So the new file is being written. Let it write the new file. I power it up using the same PIC16 programmer tool. Click on this on. It will power up the circuit. Minimize this. Zoom out. You can see that LED is bright because there is light in the room. I place my finger on the LDR to darken. See, the LED dims. Now I remove the finger. See, again the light falls on the LDR. Again I put my finger to darken it. See, it's dark now. Again it had lightened up. See, now the point here is that this LDR may be installed on the room while this LED is somewhere else on a panel. So whatever the light intensity in the room, that LED will show you the light intensity. Suppose you want to measure the light intensity of like 50 rooms, that if the light is on or off, then you can simply use this technique. You don't have to manually install any sensor or switch in the board. You just have to place the LDR in any corner of the room. If there is light in the room, light is on, this LED will turn on. If light is off, then there will be no intensity detected by the LDR. So especially for hotels, and if you want to save electricity in your room, you can use this circuit to know that if any light in the room is on or off. So that's a great circuit, great project, very cheap to make and very useful. You can make tons of applications out of it. Now see, again I place my hand on it. LED dims. There is still light coming from the back side. LDR do have, see, this indication is enough to show me that there is very dim light or it's dark in the room. Now it shows that there is a lot of light in the room, like the light is on. Again, see, it dims. I remove my hand. See. So guys, this is it. This is how you can use an LED as the indicator for the analog inputs. So if you have any questions, you can ask in the comment. I will give you all the micro C for PIC files that come with the build, hex file, C file in a Google Drive link, which will be in the description of this video. You just open that link and then you will download all the files from my Google Drive. So guys, thank you very much for your time and interest in my channel. See you in the next video. Goodbye.